Hello everyone and welcome back to our channel. Today we're diving into text analysis. We've crafted a function in Julia named unnesting_tokens and we're all set to put it head to head against its R counterpart from the Tidytext package. This Julia function doesn't just match but runs much faster. Quickly touching on Tidytext, the Tidytext package has been developed by a team of brilliant R developers and has been maintained by Julia Silge. And it has truly revolutionized the way we perform text analysis in R. Tidytext turned text analysis on its head, making it incredibly straightforward to manipulate, analyze and visualize text data in a tidy data framework. Ever since its release, I've been a devoted user of Tidytext. Its user-friendly functions like unnest_tokens enable us to perform complex text processing tasks with just a few lines of code. To kick things off, we'll be working with a Kaggle dataset, neftlix_titles, a popular dataset for text analysis projects that consists of TV shows and movies available on Netflix as of 2019, collected from Flixable, a third-party Netflix search engine. Each row of the Netflix_titles dataset includes a column called description with a review for a movie title, as you can see. Now, to run the R function within our Julia environment, we'll be leveraging the power of the rcall package. This useful Julia package allows us to execute R code seamlessly. After loading the package, the R shell within the Julia REPL is just $sign away. So let's dive into the R function and see it in action. In R, the unnesting_tokens function transforms a data frame with a column full of texts into a tidy format. Picture all those scenarios where each row of your original data frame holds a different text, as it happens with the Netflix_titles dataset. So, after loading the Netflix_titles data frame and running unnesting_tokens on the description column of the Netflix_titles dataset, we see that it breaks down the text into individual words, and then each of those words gets its own row in a new data frame. But it gets more interesting. Now each word doesn't go solo. It takes along with it all the other column data from its original row. So focusing on the first row that includes a review of the movie in the description column, we can see that this review gets split into 27 rows in the new data frame. Each of these rows now hosts one word from the review and repeats all the other column data from the original row. The same story repeats for the next text and the next and the one after that. Now, having the word as our observational point of interest, the resulting data frame is what we called a tidy data frame. Now let's switch gears to Julia. Our aim is to recreate the functionality of unnest_tokens in Julia, but with improved efficiency. Let's see how we can accomplish this by taking apart the end result function. Now, our strategy is similar to that of the original function, namely we first tokenize the text in the input column and create separate rows for each word, then we take the rest of the columns and repeat them as many times as the word tokens of each text. As with the original unnesttokens function in R, our function takes three parameters: a data frame, an output column and an input column. Here the function begins by tokenizing the input column from the data frame using the punctuation_space_tokenize function by the word tokenizers package. This function splits the text into tokens at every punctuation or space. We then also decide to select all our other columns from the data frame to separate them and then to repeat them as many times as needed. Next, we flatten the token list into a single array using the reduce and vcut functions. We then create an index list that will be used to repeat rows in the data frame. This is achieved by getting the lengths of the individual token lists and generating indices accordingly. Instead of initializing our index list with zeros, we create it with undef, which is more memory efficient. Then we fill this index list with the correct indices using a for loop. Finally, we create a new data frame by repeating rows according to our index list and add our flat token list as a new column. This is the unnest_tokens function in Julia. Let's see now whether it does what it promises to do, namely to replicate the end result of the R function unnesttokens, but much faster. To compare the two functions, I use the btime macro of the benchmark tools package. As we near the end of this tutorial, I want to take a moment to express my gratitude to the Julia Discourse community. Their collective knowledge and wisdom were truly helpful in developing this improved unnes_tokens Julia function. Julia Discourse is an incredible resource for anyone working with Julia or considering it. It's a forum where users worldwide share their knowledge, brainstorm solutions, and innovate with Julia. A quick mention goes to M. Roof's Vault from Julia Discourse, if I'm pronouncing it correctly. Their suggestions were really helpful in refining the unnest_tokens function. I hope this tutorial has inspired you to explore these tools further and maybe even contribute to the community in your own way. To stay in the loop for more similar tutorials, make sure to hit that subscribe button. Until next time, happy coding!